Hello everyone. So today we are learning about temperature and temperature scales. So temperature in scientific terms is the measure of the average kinetic energy of the particles in the matter. So it's how fast or how slow the particles are moving. Now when you heat something up, the particles are going to move faster. When you cool something down, the particles are going to move slower. All right. If we use simple terms, temperature is going to tell us how hot or cold an object is. So why temperature is important in chemistry is because when something changes states, like from solid to liquid or liquid to gas, there is a change in temperature. So chemical reactions usually happen faster, if the temperature is increased. So we'll learn about that more when we go into chemical reactions. So we have three different temperature scales that we use. We have the Fahrenheit, the Celsius, and the Kelvin. So the first thermometers were glass. They had alcohol in them, like rubbing alcohol. This would expand and contract as temperature changed. So the creator of that one was Daniel Gabriel Fahrenheit, or actually, sorry, he was not the creator of these alcohol thermometers. He was the creator of the Fahrenheit scale. The Fahrenheit temperature scale used mercury, liquid mercury. So this did the same thing as the alcohol. It would expand and contract as temperature changed. So the Fahrenheit scale was developed in 1724. It was changed after that several times. So the main problem is the Fahrenheit scale is arbitrary. So we assign an arbitrary freezing point of water, 32 Fahrenheit, and an arbitrary boiling point of water, 212 Fahrenheit. So we don't typically use Fahrenheit in science because it's arbitrary. The Celsius scale, this was named after Swedish astronomer Anders Celsius. So the Celsius scale has the freezing point of water at 0 degrees Celsius and the boiling point of water at 100 degrees Celsius. So the distance between these 2 points is divided into 100 equal intervals. Each interval is 1 degree. Sometimes you might hear the term centigrade. That's the same thing as Celsius. So the Kelvin temperature scale is going to be named after the Scottish physicist and mathematician Lord Kelvin. So this is based on the molecular motion of whatever you are measuring. So 0 Kelvin is known as absolute zero. This is when there is absolutely no particle motion. So absolute zero, it's talking about absolutely zero particle motion. So the freezing point on the Kelvin scale is 273 Kelvin. The boiling point is 373. Now notice that with the Kelvin and Celsius scale, if you're going from Celsius to Kelvin, you add 273. So that's why 0 degrees Celsius is equal to 273 Kelvin, freezing point of water. 100 degrees Celsius is equal to 373 Kelvin, or the boiling point of water. So if you're going from Celsius to Kelvin, you add 273. If you're going from Kelvin to Celsius, you take your temperature in Kelvin and minus 273. 273 minus 273 is going to give you 0. 373 minus 273 is going to give you 100. Now, I'm saying this because there are some conversions in the practice where you have to convert from from Celsius to Kelvin and vice versa. So, let's see. Oh, it does say that in here, that you add or subtract 273. So make sure, and there's a video that helps you with that too, but make sure you finish your practice questions and turn them into me.